Okay, now we're looking at domain and range. Now your domain is all possible x values. So we're thinking about our x-axis going the horizontal, all the possible x values that our graph would have, and our range is similar, except this time we're going vertical and we're thinking about all possible y values. So let's have a look at some. Now here we have a parabola. Now this is a function. If I drew a vertical line test, it would only cut once. Now what are all the possible x values? Well, you'll notice that my graph actually goes on this way forever. It would continue to go up and up and up, and to the right we also have the arrow that would continue to go up and up and up and up. So what we actually say for the domain is that it is all real x. Now what that means is that for every single real x value, our graph will continue all the way to the left and all the way to the right. Now what about the range? Your range, you'll notice from our graph, it starts here because this is where our vertex is, and it will keep going up this direction and will keep going up this direction, but there is nothing down below -5. So for the range, we actually say that the range here is when y is greater than or equal to -5. Now let's have a look at this graph here. For this graph here, if we think about the domain is the x values in which our graph is permissible, and we see that we've got -4 here, and for each x value here going along until we get to 4. So it's actually bounded by -4 and 4. So for the domain, we say, well, x is between these two values. X can be anything in between -4 and 4, including those two bounds. For the range, we see that our semicircle actually comes up here. The radius is 4, so it comes up here where y equals 4, and it ends really, our graph really is just this section here. So for this one, it is bounded, and we're actually from 0 up to 4 this time. Now let's have a look at this graph here. What have we got here? We've got an exponential graph. For our domain, what we notice is it goes down the left on for all infinity and up the right to all infinity. So for our domain, we say all real x. Our range, however, is restricted. It will continue to go up and up and up and up for all of eternity. But what happens when we get down this end is we actually have an asymptote here at y equals 1, which means our graph will continue to come down and down and down and get very, very, very close to that asymptote, but it will never actually touch y equals 1. So it's bounded by that line y equals 1. That means that for our range, it can be any y value greater than 1, but it cannot be equal to 1. Can't touch that asymptote. Okay, let's have a look at this. What do we have here? We have a hyperbola, okay? In terms of our x values, we've got this side graph here, which goes up and up and up and out and out and out and out, okay? But what do we notice? This one goes that direction and down here. But what do we notice? That of all of my x values, we have an asymptote here at x equals 2. Really, if that wasn't there, all x values would be permissible, except for this x equal to 2. X cannot equal to 2 because we have that asymptote there. So when we do our domain, what we write is we say, well, it's all real x, however, just put a little bracket there, a little comma to say, however, x cannot equal 2. Our domain is all real x except for that one part there where x cannot equal 2. And the same thing really happens for our range. My graph will continue to go up for all of eternity And in this section, it will continue to go down for all of eternity. But what it can't actually ever equal is this bit here, where y equals 0. There's an asymptote along here at the axis here, where y cannot equal 0. So when I do my range, I say all real y, however, y cannot equal 0. I should have put an x there, sorry. All real x. All real x, but x cannot equal 0, and all real y, where y cannot equal 0. Okay, lucky last one. We've got a parabola here, although it's inverted. Okay, it's actually the graph of x equals y squared this time. Our vertex here is on the side at -5, 4. Now, if I'm thinking about the domain is all my x values. It's going on this way forever and ever and ever, but it's restricted here. It never goes out here past the -5. So for my domain x is greater than or equal to -5 because it's going greater than or equal to -5. And my range, if I think about my range, well, this is going to continue up and up and up very slowly, but it will continue for all of eternity. Same with this, it will continue down and 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 down, so that all my y values will be permissible. So for my range, I have all real y. Now this graph here is not actually a function, is it? Because if I do the vertical line test, oops, that wasn't really very vertical, was it? Vertical line test, it actually cuts in more than one place. Vertical line test cuts in more than one place. So, I mean, it begs to ask the question, could the graph x equals y squared ever be a function? And the answer is, yes, it could. How can this graph actually be a function? Well, what we need to do is restrict the range. Because the problem is that the range means that when I cut it, I'm actually getting 2x values, aren't I? So what I need to do, in order to stop it there and avoid this part, well, what I really need to do is get rid of that. I need to restrict my range so that the only y values I can have is from here upwards. So what I do is I restrict the range so that y can only be greater than or equal to 4.